So one more take on this illustration. Again, I could have created some objects right here, right? Create objects in memory, and instead of storing them in some sort of an array list of references to them, I could have this hash map, right, which would simply be using essentially a key, right, and the value. That's what hash maps are. So the values are references to these objects, okay, right here. So these are the actual values inside the map. Whereas the key can be simply a hash code returned by the hash code method of the in Java, right? That is available on every object. Okay, so the actual keys are hash codes. And then if I wanted to build some sort of tree or even a network of objects, what I could do is that I could, instead of storing direct references to these objects, again, I could be using hash values that point to specific objects in this network of objects. If I wanted to organize, you know, some kind of complicated scheme like this, that different objects refer to other objects of the same kind. So instead of storing direct references, again, I could be using hash code values over here, and in order to find an actual object, I would then go to this hash map and say, okay, for this hash value, what is the reference to the actual object? And so this way I would be finding my object. So this is where this sort of like identity may play a role in what you can do at runtime. So sometimes you just need these levels of indirections because those give you more flexibility, and sometimes can improve your capacity to search, to hop around different objects, and in general improve the navigability of your system, if you will. Okay, so another type of unique identity will be primary key that is maintained by the database. Database is usually very good at organizing records with an index, typically referred to as a primary key in the database, and you can simply use database generated primary keys or otherwise database organized or provided primary keys. And there's also message digest, right? So a very typical message digest would be MD5, message digest 5, which is a fast algorithm, which basically what MD5 does is that it takes a blob of binary data, 0, 1, 0, 1, 1, 1, 1, 0, 0, and so forth, all these binary data, basically blob of data, and goes there chunk by chunk and does compute the hash value, okay? And so what comes back is, for example, 128-bit or 256-bit size a unique number which is specific to this blob of data. Basically, it's used in encryption and communication. When the data is transmitted, then the hash can be calculated for this blob of data, and the hash value can be sent separately from this blob of data. And this way, the receiver or recipient of data can, after receiving this blob, apply the same algorithm to compute the same hash value and be sure that it's the same. This way you will know that the actual content of this blob of binary data has not been altered by simply miscommunication or some kind of malicious attempt to modify this data, right? So basically what happens is that you have a piece of data, you compute an MD5 hash, okay, using MD5 hash algorithm. You can just use a library method or function to do that. And so you then, so there's your recipient of your data. What you send separately hash, right? You give them the hash, and you also send them the data. So they get the copy of the hash and the copy of the data right here. So, but they use the same MD5 hash algorithm and recompute the hash, and then compare yours and what they have computed, and they realize that it's the same, right? And you can simply, you're probably seeing websites where you have like a website where you have a link to download something, right? Download, and right next to it just basically is published MD5 value with like, the value published right here. So you can actually download this, right, and then recompute locally the MD5 value and simply compare it with whatever's being posted on the website. And this way you know that you downloaded something that you were promised to download. So these are very useful in basically specifying identity to data. So that is, there are also other types of secure hash algorithms such as SHA-1 and SHA-2, which stand for Secure Hash Algorithm 1, Secure Hash Algorithm 2, and these are basically linked to the topics of encryption and data protection, and also very widely used in communication. All right, so these are very important things. And of course, just a quick reminder that, let me just clear this up. A quick reminder that in Java, when you say new something, right, when you say new student, right, maybe we have a student class and we want to create the student and provide the name for the student and create an instance of a student. So in Java, if you have a student Java class, it actually inherits, even if you just declare it as class student. Right, class student, and specify what it does, right? But then, anyway, in Java, every class inherits from class named object, right? That's the idea of Java organization, and like I said, there is a set of methods and properties available directly off of the object class. So that's something that you need to be aware of, and it's been there since the first version of Java. That's the organization of Java, so that everything in Java, every class in Java derives from actually class named object, right? So that's something that is available in every object. Okay, so let's continue on with this. So this way you probably get some ideas that actually objects may have specifically used identities, and that's something that could be interesting to us. So primitive data types themselves are also objects because they're just primitive data types, but they come with the value and behavior, the state and behavior. So they're just primitive versions of objects. Class is basically something that allows us to reorganize or regroup the data at runtime and provide certain boundaries of access to different parts. For example, you know that so that, for instance, we may have a situation where we have our program, right? Our program right here, stored as some kind of compiled Java bytecode, set of Java bytecode files, or it could be a compiled program such as an executable file that is already compiled and it's stored in native binary code, right? And so most likely this is stored on some sort of file system on disk, right? So we have on disk, we have stored this a set of files or a single file that represents our program. Then at some point we actually say, okay, let's load this program into computer memory, right? So this will be our computer memory right here. Okay, and we would like to essentially start executing this program. So this is our program already loaded and ready to be executed. So we know that in both Java and C, what happens first is it's almost like I want to zoom in into a certain portion over here and say that some kind of main method or main function in C begins to execute, right? So this is all 0 and 1, 0 and 1, 0 and 1, essentially some set of instructions that starts to execute basically sequentially, right? But as soon as main starts, what it does, it gets its own frame on the stack where all of the local data, right? So the actual data exists right here on the stack, and we can refer to this as stack frame, also known as sometimes in Unix environments called activation record, right? But before each method or function is invoked, essentially it's given this place to store the local data. Furthermore, this function or method, right here, can make a call to another function or method, right? So say initialize, init some data, okay? And this also begins to execute its own instructions, but before it starts execution, the same thing happens, is that it gets its own stack of execution allocated prior to this to execution of it, and this portion of your program, right, it will have access to its own stack. And so that basically goes on and on and on. And if we then kind of basically recycle this view to be our view of like graph of function calls or method calls, right? So then we will repeat this this view over here as well, because for every call we have to deal with the fact that the actual data is stored somewhere here on the stack. And as we begin to return, right, so as these function calls or method calls return and these things essentially disappear, right, likewise the actual stack frames holding the local data are destroyed, and they just no longer basically no longer needed, right? So they're no longer used and no longer being the memory which is available to your program. But the fact of the matter is, so the local variables, like if our programs right here want to say, for instance, integer x in part of this executable code, create an integer, this integer will be populated, of course this would be my other method or function that is currently executes. But if I did have an integer x declared over here, this integer x would of course be created here on the stack. This is the actual location of the variable, right, in computer memory, because this is computer memory. This portion right here is executable code, and these pieces are essentially those stack frames allocated to every single call, right? So that's what's happening, but this X will not survive the ending of this method or function named init, right? So as soon as this returns, X will be destroyed and will be no longer available. So therefore, we also may need some other type of data, right? So basically the data which is shared by all portions of the program. So that all of these may want to have access to certain data which is located in this so-called global memory, right? And we want to be able to share some data which survives function calls, right? So if this, for instance, right? So if this specific method returns, right, and its own stack frame is destroyed and returned back to the system, the memory is returned back to the system, and this connection no longer represents anything meaningful, right? So it's basically we can just get rid of it. If I can do this basically by erasing it like this, right? But at the same time, the data that has been potentially used by this code remains in global memory. So this is the idea of object. Essentially, this is procedural programming model, and this is purely like what happens at runtime when this program starts to execute and starts making calls to different parts of the program, right? But in object oriented type of design, right? Design of the system. What happens is that we actually want to be able to associate certain methods or functions, right, with certain type of data, because we notice, for instance, if we're dealing with the date, right, which has month, day, and year, something like that, we just notice that everything that happens with respect to this date actually manipulates these three pieces, and so it just makes sense that all methods that deal with dates supposed to be organized into something that looks like a class, which essentially groups together month, day, and year with all methods that allow you to compare months, change month, assign new values to the date, and do the computation with it. So essentially what it does, the object-oriented technology essentially groups certain methods with certain data, and also allows you to create boundaries, right? So this could be a real boundary in the system, so that month, day, and year, although of course they're stored somewhere here, right? They're still maybe stored somewhere in this global memory. However, other methods, if they don't belong to the date class, they cannot access the data. Only the methods that are declared inside this date class will be able to directly access month, day, and year. Everybody else will have to find a public method to call in order to be able to manipulate that, right? So again, at runtime, it's still the same picture. It's mostly at the design time that we essentially use a slightly different approach to organize the way we manipulate data, the way we access data, the way we restrict access to data, and that's what the class is for. Essentially, class, of course, gives you the structure, right? So this is like the structure of your data right here, right? But at the same time, it allows you to add methods to these classes, right? We say that generally speaking, class represents an abstract data type, and data type suggests that basically new variables of this type, new objects of this type can be created, right? So like we said, we can say that, for instance, if I have an object of type a work schedule, right? Something like this. And work schedule is simply a collection of time slots, right? Like time slot will be like from to and so forth, right? So this type of information is a time slot, and of course, and some field that represents the employee, which is being assigned this time slot in the schedule, and of course, there could be other important things to consider, such as whether when we're doing this, is this a weekday, right? Is this a weekend? Because the pay can be different. Is this a holiday, right? And sometimes this could be used also in situations where you want to use this time slot and use it specifically as a sick day, because sick day can still be a paid sick day, right? So it could be put on the schedule, used as a sick day, and accounted for and used this way. So there could be other ways that you want to associate information with all of this, and of course you can also have an employee, right? Employee with the name, social security number, pay rate, and other things, right? So all kinds of information about the employee, and the employee, of course, will also have its own field somewhere in a time slot. But it just doesn't make sense to make employee responsible for doing some computation related for weekday, weekend, holiday, or sick day, right? It's purely responsibility maybe of a time slot type of object interacting with these. So essentially, using these boxes kind of demonstrates that certain data can be manipulated here, right? In this area, right? Some data can be manipulated here, whereas other type of data we want to be able to manipulate over here, and so a different type of data is accessible to an employee, and work schedule has nothing to do with an employee social security number, right? So that's just an obvious kind of like decision to make when you're designing your system. However, if this is a purely procedural programming, the data is really not well protected in that environment. So object-oriented environment allows you to isolate the access to data and even make the data private. So that's just an approach here. Again, data attributes and operations, that's just a combination that makes up the class. Let me save this segment.